Welcome back, everyone. In this lecture, we're going to begin discussing using GPUs with PyTorch. Typically, for larger networks dealing with large datasets, training on a GPU, that is a graphical processing unit, will be much faster than training on just a normal CPU. Keep in mind though, not every computer will have a suitable GPU for PyTorch, so there will be certain restrictions on your hardware in order to actually use GPU for PyTorch. Let's briefly discuss why typically GPUs are faster for deep learning processes, as well as if your computer will be able to use PyTorch on a GPU. The backpropagation process, as we know, is already highly dependent on matrix multiplication. And for specific matrix multiplications, GPUs are much faster. But then, why are GPUs better at this than a CPU? This really has to do that fundamentally, GPUs have many more logical cores, that is, arithmetic logic units, or ALUs, in their overall hardware structure design. So here we can see a CPU versus a GPU. And again, typically the GPUs are going to have a lot more of these ALUs than a CPU would have. So the GPU allows for an increased ability to process simple operations in parallel. Now, NVIDIA, that is the graphical card company, created a parallel computing architecture known as CUDA, which gave deep learning library developers the ability to write code for parallel processing on a GPU. So essentially, we can think of the GPU as having this innate capability of running a lot of processes in parallel. And then NVIDIA created this computing architecture, CUDA, which then allows people who develop libraries such as TensorFlow or PyTorch the ability to actually write these programs to run very efficiently and run in parallel on that GPU. So then this allows for GPUs to have much larger bandwidths for processing information. And here we can see the theoretical limits of gigabytes per second for GPUs versus CPUs. And here on the bottom, you can see the blue over the years as kind of slowly increasing in bandwidth. But however, there's been very large jumps made in GPU bandwidth throughout the years. Now, CUDA, because it was developed by NVIDIA, is currently limited to NVIDIA hardware. And PyTorch specifically uses CUDA for its GPU acceleration. And what this basically means is that in order to use GPUs with PyTorch, you must have an NVIDIA GPU card. Now keep in mind, this is a very fast developing field, and there are some other alternatives for trying to run CUDA-based architectures on non-NVIDIA hardware, but that requires a lot of manual work, and even then it's not guaranteed to actually properly work, especially with something like PyTorch, which is specifically designed to work with CUDA for GPU acceleration. So what we're going to say is that in order to actually use GPU with PyTorch, you're going to need NVIDIA-based hardware. So if you're watching this and you don't have an NVIDIA-based graphics card, then for the time being, you're not going to be able to use GPU with PyTorch. So then what options are there if you don't have that actual NVIDIA GPU card? Well, there's lots of online cloud services that allow you to have access to NVIDIA GPUs on the cloud. Things like Amazon Web Services, Google Cloud Platform, and Microsoft's online services of Azure. Keep in mind, these are usually not free, so you will probably have to pay in order to use these cloud services in order to run PyTorch on the GPU. And these are often being updated, even sometimes as quickly as month-to-month updates. So I would highly encourage you to check out the actual Amazon Web Services, Google Cloud Platform, or Microsoft Azure websites to be able to quickly get up and running. These services change very, very fast, so we're not actually going to show you how to use them. Instead, we're going to link to you to their official documentation how to use them in order to be up to date to the latest updates onto the platforms. So again, this is an extremely fast changing field, and it essentially changes from month to month. So what we're going to say is we do not offer officially help with personal installations of CUDA because in reality, every situation is going to be different. It's going to depend on what version of Microsoft Windows you have or what your operating system is. It's also going to depend on what actual graphics card you have. And then it's also going to depend on what installation of CUDA you end up deciding. There's different versions of CUDA. So as you can imagine, there's different versions of Microsoft OS, there's different versions of CUDA, there's different NVIDIA graphics card, and that's all going to come into play. So there really is no general guide we can give you that would cover all of these options. So instead what we're going to do is we're really going to focus on leading you to the official documentation that's updated by NVIDIA and CUDA in order for you, that if you so choose to use GPU with PyTorch, can reference those websites and get the latest information. Otherwise, we would have to keep updating an installation video every couple of weeks, which doesn't really realistically make sense for us. So again, please check out the supplemental resource links in this lecture for installation guides and instructions. We've also gone ahead and linked you to different cloud offerings that basically already come with PyTorch installed and ready to go. As we previously mentioned, those will not be free, and you may have to pay for them. Now, I'm going to quickly explore a few of these useful links in order to give you an idea of how to actually kind of run GPU with PyTorch. All right, here I am at pytorch.org. Keep in mind, pytorch.org, it may look slightly different depending on if they update the website by the time you're viewing it, but somewhere around here there should be a Getting Started tab or an Installation tab, and we've already seen this a little bit at the very beginning of the course, but there are essentially a couple of options here: Start Locally, Start via Cloud Partners, and then Previous PyTorch versions. So let's first go over the cloud partners, assuming you do not have local hardware access to an NVIDIA GPU card. So if you click on Start via Cloud Partners, PyTorch will have here the links to the latest cloud partners. And we can see here that there's AWS, Google Cloud Platform, and Microsoft Azure. So if you click on these, they give you a couple of different options. And then if you just click on AWS and scroll down without clicking those options, it'll give you the latest guide on deep learning with PyTorch on that specific cloud platform. So it has step-by-step instructions here, and these are going to be updated to the latest versions. So we're going to go ahead and reference you to this official guide on using PyTorch with AWS, because this could change from month to month, and it will be updated here on this website, instead of us having to refilm this every couple of weeks. So then there's also quick start verification, etc., and you can go down. So there's a full step-by-step guide. It's numbered 1, 2, 3, 4, etc. And then if you want, you can click on these links. So if you click on Amazon SageMaker, it will take you to the official PyTorch on AWS guide. You can scroll down. It has a Getting Started tab here, clicking example notebooks, etc. So keep in mind, you would need to create an AWS account for this, and you may get charged for using this. Please contact AWS support if you're interested in their pricing information. We do not officially support that pricing information because it could change from month to month. Not only is there AWS sources, but there's also Google Cloud Platform. So if you scroll down here, it gives you the full guide on using PyTorch with Google Cloud. If you click on that actual link, it takes you here to this guide on creating a PyTorch deep learning virtual machine instance with, again, step-by-step instructions. And we would highly recommend you check out these step-by-step instructions. And this is basically the most official, up-to-date guide that you're going to be able to get on using PyTorch with deep learning and on Google Cloud Platform. Okay, and then finally, there's also, if you scroll back up here, there's Microsoft Azure. It has, again, a full guide, Azure Primer, GPU-based virtual machines, etc. And if you click here, it'll tell you about Azure Machine Learning Services, and so on. Now, keep in mind, you may see here that it says Start for free, and you'll also see this on Google Cloud Platform, Get Started for free. But again, I highly recommend that you contact the support teams of those actual services if you have any questions over pricing. We do not officially answer questions on pricing because pricing could always change, and we want to make sure that you fully understand what costs you may have associated with running a GPU on one of their platforms. Their free tiers change often, so again, if you have any questions on pricing, please contact the cloud platform provider directly. Please do not ask us about pricing information for these various cloud platforms. Okay, so that's running everything on the cloud, which is probably the easiest way to get started, although it may cost you some money. And if you want to get started locally, we saw here that PyTorch basically has everything set up. You choose your build package, your OS. So we have Linux, Mac, and Windows. Then you choose your package, Conda, pip. We've been using Conda. Your actual version of Python, so Python 3.7, and then CUDA. So note here, if you're using Mac, Mac OS binaries don't support CUDA, and it's unlikely that you're going to have an NVIDIA GPU card on a Mac OS product. So again, we leave that up to you to install CUDA yourself if for some reason you're running Mac OS and also have an NVIDIA GPU card. Keep in mind that is not really a common situation. Now, if you're running Windows locally, you're using Conda, you're using Python 3, and you already happen to have an NVIDIA GPU card, you're going to need to install CUDA first. So currently the versions supported are 9.2 and 10.0. Now, if you don't have CUDA and you just wanted to run this on CPU, you would run this command. However, let's imagine that you do have CUDA, or you need to install CUDA. What you would do is you would check out NVIDIA's official CUDA Toolkit installation guide. So currently, while I'm filming this, the latest version I believe is 10.1. So what you can do is either Googling or just go to developer.nvidia.com/CUDA-downloads, and it will take you to the download update page for the latest CUDA toolkit. And essentially what you would do is you would pick your operating system. Again, you must already have the NVIDIA GPU hardware. If you don't have that, then you really can't use this. But let's imagine you're on a Windows computer, you have an NVIDIA GPU card, you would click here on Windows, choose your architecture version. So let's say you wanted 10, and then you would either choose a network installation, or more likely if you're running this locally on hardware, you would choose this executable local. And then you would essentially go through that. There's official documentation here if you want to check it out. There's full installation guides. So what I would highly recommend is you check out these installation guides. These are going to be the latest installation guides. So again, instead of having to refilm this every couple of weeks, you would just follow here with this introduction and follow step by step on their installation guide. If you have any questions on this, please reach out to NVIDIA or their support teams, because again, NVIDIA may change CUDA much faster than we're able to update this video. So I would highly suggest you check out the supplemental links here, and these are the most up-to-date official guides from NVIDIA. And then once you've downloaded CUDA and had it set up with your local NVIDIA GPU card, then you would choose based on which version you downloaded. So let's imagine we just downloaded 10.1 and installed it on this computer. I would select 10 and then would conda install PyTorch and then copy and paste this command. Keep in mind, you should do this in a separate environment than the one we provided for this course. We do have a GPU environment, however, that's going to be dependent on what version of CUDA you have. So I would highly recommend that if you happen to be one of the people that has a local computer with an NVIDIA GPU card and you went ahead and installed CUDA, go ahead and just create a new environment and then run whatever command this PyTorch officially tells you to do. Okay. Now again, there's also a full instructions here on installing on Windows, and you can check those out as well. All right. So again, a lot of this is going to change from time to time, so we highly encourage you to check out the official links. There won't be any better guide than what's officially provided by these cloud providers or by PyTorch, so we'll go ahead and add those all for you in the supplemental resource link for this lecture. Coming up next, we're actually going to show you how you code slightly differently using PyTorch in order to make sure you're using GPU. We'll see you at the next lecture.